Alright, let's review rotation. So this is video rotations part 1. Two types of rotations that you've done already is, part 1. Rotation around the origin. So if you look at this red rectangle here that's already moving, the black one's our original figure, and it's rotating around the center point. And I don't know if I can put a point on there. So it's rotating around the center object here. So if we say once it completes its turn here, either it's done a 180 flip, or 180 rotation, or it's done a 360. And I know it's hard because I don't have my labels on it here. But I guess I could put, so if this is corner A on the black one, when we get up to a 90, we're going to have this one as A prime. So it's going to have a temporary outline there. So that's a 90 degree, the first one, clockwise. Then we're going to have, when this reaches down, we're going to have the second figure image, and that's going to be 180 degrees. When it rotates down here one more time, we're going to have another shape, and my A is still this far right corner, and this would be my 270 rotation. Nope, not there. It would be the front side. Right there. Which means this one's wrong. So if A is that leading corner, it's got to be the leading corner going in it the whole time. Okay. Okay, so now if we look, so that was again rotating around the center, right here. So now if we look at what happens if we rotate it around one point. So, alright, we're going to try and rotate around the corner. So let's see which vertex it chooses. So, and unfortunately I can't write too close to these, but I'll get the labels on afterwards. So we're going to rotate. So that would be our 90, 180, 270, and back to its original 360. So notice in the corner that they have the little crosshairs, the T, if you want to call it that, so that we know all our 90 degrees, so that we can keep going around and around as many times as we need from, from that corner. Now it's going counterclockwise. So if we look at the letters, and if we were to call this original one over here A, let's follow where A ends up each time. So if we know that this is a 90 degrees, our A corner is over here. We can see that there that just passed was 180. Let's follow that A corner. There's A. I guess vertex is the better vocabulary. And if this is our other 90, there's A again. Okay, so there's rotation from the center, from a corner. I'm just trying to get it to rotate the other way. Let's happen. We have one last type of rotation, and that's rotation around a point that's not attached to our object. So here, if we pictured our Cartesian plane, we could be rotating around the origin. I could make the rotation point over here, but for now we're going to ignore the Cartesian plane, but picture it as though we're rotating it around the origin. So let's get rid of... And now I can't erase that. Hang on a second. There we go. Okay, so we're going to take this object and we're going to rotate it around the point. The point we're rotating is over there. Okay, so let's move this rotation point down here. Again, see the little crosshairs? That's where we're rotating. And now if you look, there's still those 90 degrees, and we're going to show where these 90 degrees show up when we rotate it. So we're going to rotate this around. So there's 1, 2, 3, and then back to 360. So we'll let that play out, and you'll notice a couple things. You'll notice that this arm will be out there, and we'll see once it gets there if I've drawn it long enough. And if we compare this rotation to the first rotations where it was around the corner or even around the center, you'll notice that the rectangle is oriented, so it's turned the same way as it has the other time. So this type of rotation does two things. It moves it from a physical different location, so there you can see it was 90, and it turns the object, so it does two things. So there's our first 90. If we extend this arm out this way, it should meet up there. There's another 90, or you can think of it as one straight line, as a 180 degree turn, and it should be lining up. So right there. Okay, so I was a little bit off of my first line. But again, if you look at your 180 degree from the last two, it's the same orientation. It's this horizontal rectangle. And then the last one, of course, he's going to get back over here. And there's our other 90. And some of the rectangle might be cut off. But again, now it's a vertical rectangle. And right there, it's at a perfect 90. So my lines are a little bit off for this, but if you practice, if you had a string or a popsicle stick and you attached your object, it would complete that proper rotation. So again, rotating around a point is more difficult, but you have to make sure that you're turning your object. So you rotate the physical rectangle, you rotate, and you rotate its a location around that center point. If we were to look for letters, so if I called this vertex or this corner of the rectangle A would be down here, A would be over here, and A would be over here. So again, if it's at that leading corner, it's going to be the leading corner going forward in all of them. Okay? And those are your 3 types of rotations. So one last thing, again, you could picture, let's do it in yellow. You could picture this as a Cartesian plane. And when you rotate, you have to think about what type of, there will be patterns with your ordered pairs or with your coordinates. So this quadrant 2, you know that all of your ordered pairs are going to be negative positive. If it rotated 90 degrees clockwise, all your ordered pairs would be positive positive. If the original did a 180 degree clockwise or counterclockwise, you would have negative or positive negative coordinates. If it did a 270 degree rotation, you know it's going to have negative negative. So being able to check your work by the value of the ordered pairs, being negative or positive, is one way, and you'll also be able to look at patterns when you're rotating around the origin. If you were rotating around a point over here and you rotated that rectangle, it's a lot more difficult to find patterns, but you could still check by knowing if it should be positive or negative depending on the quadrant that the object's going to lie in.